I am very pleased to introduce Michelle de Blasio, TNC's Watershed Restoration Coordinator. She's been with TNC for almost 6 years, so you may have seen Michelle talk about her work in planting over 60,000 trees, shrubs, and grasses in the Paulins scale, or the additional 35,000 trees planted as part of the Roots for Rivers program. You're about to find out that Michelle brings the same energy to our water quality monitoring program that she brings to floodplain restoration. Michelle will share some of the monitoring methods that we use in the Paulins scale, including some of our work done this past summer. That's particularly noteworthy because around the country, and in fact around the world, 2020 will represent a huge gap in many scientific data collection projects due to COVID pandemic. Typically, Michelle has 2 or 3 seasonal employees on hand to help with all of TNC's monitoring work, but this year, due to the pandemic, it was all Michelle. So please enjoy the presentation of our water quality monitoring work with an emphasis on some of the cool technology we use to get it done.
Thanks, Beth, and hi, everyone. Thank you for joining us today. As Beth mentioned, I'm Michelle, and I've been helping to lead our water quality monitoring program in the Paulins skills since the beginning, back in 2015. And since then, I've had a really unique opportunity to watch this program evolve and grow over the years. Today, I'm really excited to provide you all with a behind-the-scenes look into what that program looks like, and to hopefully bring you into the river and leave you all with a better sense of how we collect scientific data to help tell the story of our conservation work. And so many of you are aware of our conservation projects that are happening right now on the ground in the watershed, in the Paulins scale. And so we have projects ranging from large-scale wetland restoration work in the upper portion through the hyperhumus wetland restoration project to our 50,000 tree planting goal that's happening across the watershed, to our Bobcat Alley land preservation initiatives, where we're buying and protecting and preserving land in these critical wildlife corridors for threatened and endangered species like bobcats. And then we have our upcoming dam removal projects that are happening all along the main stem, which aim to reconnect migratory fish habitat. And so all these projects combined serve really one big overarching goal, and that is to improve water quality in the Paulins scale. And so the benefit of working in this one distinct region, in this one area, is that all the changes we make in this landscape are actually going to affect one central point or one central location, because we're working in one drainage area. And so that central point is the Paulins scale. It's the main stem Paulins scale. And so what I'd like to do is just orient everybody to the watershed and give you a good sense of where our projects are within this landscape. And so the main stem is this dark blue, and it starts up in the headwaters in Newton, and it flows north for a little while, where it goes through for about a mile through the hyperhumus wetland restoration site. And then it takes a turn west, where we get into one of our larger reforestation corridors. This is about 4 miles along the main stem. We have just maybe over 20,000 trees in this section alone. As we start to go down south through Hampton, Stillwater, we hit our Bobcat Alley delineated protection corridor. You can see in the dark green, we have all the different preserved lands that we've acquired over the years. And as we move down the main stem into Blairstown, we get to our Paulina Dam removal site. We have the county line slated for removal. As we trickle down to the confluence with the Delaware, we have our former Columbia Dam site. And then all throughout, we have some more orange blobs. Those represent all the other tree plantings that we've installed throughout the years. And so we have all this great work happening on the ground. And when we wanted to determine changes in water quality from all this work, it was really important that we developed a sampling network that represents and speaks to these pre-post project conditions. And so all these yellow dots in addition to these green squares, this is where all the different data is being collected in the watershed. And so you can see we have them strategically located up and downstream of dams. We have some, in our reference sites up in Bobcat Alley. And so we really made sure that we had adequate cover throughout the watershed to really be able to assess water quality conditions in the watershed, but also to determine pre-post project impacts. And so what do we measure? Well, there's a million things that you can measure when you start to get into water quality, but we really wanted to make sure that we were collecting the right information that's going to really help to capture those project impacts. And so what science fit with our work? I want to walk you through just a few different key indicators, water quality indicators that we use to help document baseline conditions in this watershed. So macroinvertebrate sampling. Macroinvertebrates are just the critters that live in the streams. They live under the rocks. They're a food source for fish and other aquatic species. And they're most often used to assess stream health because, for one, they're really easy to collect and identify. And for two, different species actually differ in their tolerance level to different pollutant loads. Meaning some species can survive really, really dirty polluted waters, whereas others are really sensitive and can only live and survive in really good water quality, free of pollutants. So by assessing these different communities and seeing, who's where and how many of what, we can really begin to start to see really short-term impacts to water quality just by looking at the macroinvertebrate community that's within these stream reaches. So each spring, we visit 23 different sampling locations throughout the watershed. We collect our bugs and then we send them out to the lab for analysis. As Beth mentioned earlier, COVID-19 has definitely affected much of our work, but especially our water quality monitoring program. And unfortunately, we weren't able to get out to those 23 sites, but we did still manage to get what we consider our priority sites. We still were able to get to some. These surveys take a really long time. They take about 1 to 2 hours to complete just one of these surveys. And once we collect the bugs, we also perform a visual habitat assessment. And so this survey is performed within the exact same stream reach that the bugs are collected. We follow the Environmental Protection Agency's rapid bioassessment protocol. And this protocol really is just assessing both the in-stream and the riparian zone for different habitat characteristics. And so each of these different habitat characteristics or different features are scaled from 0 to 20. And different features like area of the width of the riparian zone, or how stable the banks are, the available in-stream cover, sediment deposition, those are all ranked, and then an overall assessment score is spit out based on all these different features. So up here you see, this picture shows a very heavily forested, stable riparian area with lots of riffles and runs, lots of available cover. So this would give us a really high or excellent score. Whereas something over here that we see might give us somewhere in the middle. The in-stream has pretty good habitat conditions, but it's smack in the middle of a park. We have a tennis court over here. We have a paved lot right over there. So the riparian zone, not the best in terms of habitat conditions. So again, this would probably fall somewhere in the middle of that habitat assessment. And then we take a deeper look at the actual bed substrate. And so we do that through performing pebble count surveys. And so this survey is really to assess the makeup of different sediments by measuring different size classes of the stream bed materials. So big boulders versus cobbles versus small particles. And really this allows us to assess the distribution of those bed materials within these select stream reaches. And this survey becomes particularly important for our dam removal projects, where we would expect to see pretty drastic changes to that bed material pre and post removal. And then we get into what I like to call our hard science indicators. Temperature affects all living organisms in the stream. Some require certain thresholds for survival and reproduction. So throughout our reforestation corridors, for instance, we're hoping to improve or decrease temperatures to get those within more suitable ranges for certain fish species and different aquatic organisms. And so we can assume that over time, as those trees mature along the banks and begin to shade the stream and the river, ultimately that's going to give us more canopy cover. It'll help to bring down those stream temperatures and over time maintain them for the aquatic species that live there. Dissolved oxygen also directly affects the critters that are living in the stream. And just like you and I require air to breathe up on land, so do the critters in the stream. And so dissolved oxygen is really a good measure of the available oxygen in that water column for different species. And so typically cold, fast flowing water will hold more oxygen and thus yield higher concentrations of dissolved oxygen. So in areas like hyperhumus, the wetland restoration project site, we see very low levels of oxygen due to very stagnant, low flow conditions. So restoration of this site, we aim to improve or increase those dissolved oxygen levels to support aquatic life. Conductivity is simply the water's ability to pass an electrical current or electrical flow. Certain ions like salt are able to pass at different rates. And so when in the wintertime, when we go out and we salt our roads, a lot of that salt ends up in our streams. And so we can actually see spikes in conductivity during the winter months due to this higher concentration of salts in the water. So areas like Bobcat Alley, where we have these really nice forested stream buffers, able to catch that runoff from the road and kind of stop the salts from going in the river, if you will, we see very low or good optimal ranges for conductivity. And lastly, but certainly not least, we have turbidity, which is simply a measure of the cloudiness in the water. And so as sediments move through the water column, they dissipate out in that water column. And so we measure to see how much is passing through. And so areas, say, above a dam, we'd expect to see really high levels of turbidity. And so this is really important parameter to measure because changes to the water quality via dam removal will actually be able to see a pretty drastic decrease in turbidity levels post-removal versus pre-removal. So how the heck do we measure all this information? So just like there's a million different things that we can measure, there's also a million different ways that we can actually collect this data. And so the macroinvertebrates, the habitat surveys, the pebble counts, all those are fairly straightforward in that they require little to no equipment to get in and collect the data. But the last parameters, the last indicators, those hard science indicators, those require a little bit more technical savvy, if you will, to collect. And so we use 3 different methods for collecting this information that we'll go through. So discrete sampling is simply just using a handheld meter or a handheld sensor to record data at one particular place at one particular time. And so they make, a bunch of different meters. It really just depends on what sensor, what data you want, depends on what meter you would buy. So our meters, we have one for turbidity, and then we have another one that measures temperature, conductivity, and dissolved oxygen. And when we began our monitoring program, this was really the main means of data collection. We were using these handheld meters, and we were able to collect a snapshot of what the river was saying at that particular time and place. But we realized that this method was really limited. It was giving us a very limited assessment of what the conditions were or baseline conditions were across the watershed, because again, it's only giving you that snapshot. So you can't really say what the average stream temperature is if you're really only going and collecting data at 7 a.m. on June 22nd. So we needed a way to really collect more information if we wanted to document trends in water quality and really start to begin to build a baseline and determine what these water quality conditions are pre and post project removal. So by the second year, we transitioned into continuous in-stream monitoring, or CMI. And this is just a means of, it's the same as using a meter, except instead of just taking a snapshot, you're collecting a continuous record of information. And so we use two different meters. We have a Hydrolab HL4 multi-parameter sonde. We also use Hobo's U26 dissolved oxygen logger. And just a side note, sonde, logger, meter, they're all interchangeable names. They're all the same. It's a piece of equipment that has a sensor at the end that's recording data. What the difference in sensors and manufacturers just call them different things. And so the Hydrolab that we use, we have 4 of those that operate. We have a turbidity, conductivity, dissolved oxygen, and temperature all on that one probe, all on that one sensor. And then the Hobo dissolved oxygen loggers, those are collecting dissolved oxygen and temperature. And we have 12 of those. And so all 16 of those loggers sit in the stream year after year. And how does it work? We don't just throw these in the river and expect them to come back to us and give us all of our data. We have to make sure that they are in the river safely. And we do that by putting them inside this housing unit or this base unit. And essentially what it is, it's just a 60-pound bag of concrete mix, nice and light, easy to throw in the stream. And we attach a PVC pipe to the top of it that we drill holes in to allow enough water to pass through the sensor. And then we put a little name tag on it that just simply says, hi, I'm a water quality device. I'm measuring X, Y, and Z. I belong to the Nature Conservancy. Call me if you have any questions. And so that way, if anybody stumbles upon these things in the river, they have any questions, they can give us a call. But also, we try to prevent folks from moving them when they're out in the stream. So we try to make it clear that, I'm doing something here. Please leave me here. And then we, fasten the logger inside there to the name tag. And we actually got this model, this base assembly from our partners at the Delaware River Basin Commission. And when we first started sampling, we felt pretty confident that if our partners, use this base assembly to collect this continuous data in the Delaware River year after year, which experiences really high flows, we felt pretty confident that it would withstand the flows of the Paulins scale. So once we get our loggers in here, we go out to the stream every year and we deploy them. And year after year, we put them in the same location because we really want to make sure that we're collecting consistent data year after year. And so you want to make sure when you put these in that they're nice and flat, they're free from any, potential damage from fallen logs or anything like that. You want to keep them free from debris, make sure nothing is going to affect or knock your sensor out of place. It's important that you situate them in areas of flow to ensure water is constantly passing through the PVC pipe and past the sensor to the logger. Any areas that experience higher than usual flows, we double, triple cable wire them to a nearby tree just to make sure that actual basin logger don't go anywhere. We safely tuck away that cable wire underneath rocks so anybody out recreating, there's no chance of them tripping over it or anything like that. We make sure that the logger is safe, that the base is safe, and anybody that goes near these things is safe as well. And once they're in the river, they begin recording data every 15 minutes. They live in the stream for 6 months every year from April through October. And again, due to COVID-19, we had to modify our CMI this year. And although we got them all in the river, we are modifying the actual sampling window that we'll have them out for. And so instead of capturing data for 6 months, we are only doing 3 months. And we're ensuring that we're still getting the hottest times of the years when we would see those high peak stream temperatures, which is really important when we go later on to analysis, but we just don't have the bandwidth to keep them in for much longer, just for this year. So once they're in the stream for 6 months, we don't just leave them in there for 6 months, this year 3 months. We have to go out and routinely check them. We check them every 2 to 4 weeks. We visit each and every site. We offload the data. We run through the data. We make sure that everything is functioning properly, that our readings are stable and that the calibrations are all on par. And so the way we do that is we use one of the handheld meters and we cross-check the continuous meter to the handheld meter. And so we just want to make sure that there's no drift in between the readings. And if there is, we would have to bring the sensor back in to the lab to perform calibration to make sure we're getting accurate and precise readings from each of these readings. It's just a measure of data quality, data control. And so in addition to offloading the data, managing the data, we also have to clean the sensors. So we often experience biofouling, which is just when algae or diatoms or different critters that live in the stream, they love our sensors, they attach to the logger bases, they attach to the PVC pipes, they also attach and grow and reproduce on the sensors. And so it's very important that we get that biofouling off, we clean the sensors, because over time it really does cause wear and tear, and you would be getting false readings if you don't get the biofouling off. So it's very important that we do these routine checks. And at the end, we analyze everything for daily averages, daily maximums, and daily minimums. It's really going to take a long time to start documenting trends, but we've definitely laid the foundation to do so. And as great as this CMI is, and as much data that we get from them, it's allowed us to collect so much valuable information about the pollen skill, but it doesn't come without its challenges. Sometimes the river doesn't even let us go in and sample. Sometimes it's, so low that the sensors aren't even in there, right? So we've definitely evolved over the years and really learned how to not only just work in the river, but work with this equipment and really get it to what I like to consider a well-oiled machine. And so although we still have our challenges, we've definitely conquered the big hard stuff. And just like our projects on the ground are evolving, so is this program. And so every year we definitely make sure that we are doing the best we can to collect the best data possible. And more recently, we've actually transitioned into one of our newer methods for data collection, and that is remote sensing. So remote sensing, similar to the CMI monitoring, where we're collecting continuous data, but instead of manually offloading the data, we're actually able to access this information remotely through online data portal systems. And so remote sensing is actually one of the most efficient and effective methods for continuous data collection. And fortunately for us, through our involvement in the Delaware River Watershed Initiative, which is an initiative funded by the William Penn Foundation, one of our partners through that collaborative actually began designing and manufacturing these remote sensing stations, and then they started giving them away to members of the DRWI. And so in 2017, we snatched one of these up. We, tried to learn how to use this, but at the time, Stroud Water Research Center was really hands-on in, operating these. They put together these data loggers. They put together the Mayfly station, and over time, the program became so big, it became such a hit that they really couldn't do that for everybody anymore. So although they wanted to still make these and manufacture them and give them to members of the DRWI, they wanted to, kind of get more hands off and place more of that responsibility in the hands of the user. And so again, although it started as a giveaway program, they kind of had to transition. The program really blew up, as I mentioned, and they were, transitioned from this giveaway program, and then they started, making it more of the responsibility of the user. And so we recently purchased 2 more. We said, it's fine, we will take on the responsibility. We would like 2 more, we love these. And so just this spring, I participated in a 2-day online training, and they walked us through how to actually assemble and put together this Mayfly data logger. And the training was great. It really was digestible. Believe it or not, I know it looks pretty technical. I'm not going to lie, when I got the box from Stroud full of parts, I was a little scared to open it, but it really wasn't that bad. And essentially what we did is we just programmed this data logger board to speak to the sensors. So the sensors are, this is the board here, and then we have our sensors here. And so really, all the training was getting this board to speak to the sensors, and then you want the board to speak to the online platform. And then you also connect it to a cell plan, which transmits the data to the online platform. And once you have all this hooked up and running, you assemble it inside its home, essentially, its safe box. And again, unfortunately, because of COVID this year, this was supposed to be a 2-day in-person training where the first day they were going to teach us how to assemble it, and then the next day we'd go out in the stream and they'd teach us how to deploy them on our own. But unfortunately, because we couldn't meet safely in person, we did this online training to get it assembled, and then they sent up field representatives to help deploy it because they weren't able to provide that full training just yet. And so just a few weeks ago, I met my colleague Krista, who works part-time with the Stroud Water Research Center. We spent a socially distant day together in the field deploying 2 of our new sensor stations. We have these now placed up and downstream of the Paulins Dam project site. And essentially what you do when you get out there is this PVC pipe here. It just drives into the riverbank. The sensor is actually at the top end of the PVC. You can see it a little bit better there. And then you run the sensors up on the bank. You drive in the actual housing unit, which the logger's in there. Here's our sensors, those run to the stream. And then you attach your solar panel, which is the main source of power, but there is a backup battery in there just in case you don't get enough sunlight in one day. And once it's connected, the data starts transmitting data via cell service and is instantaneously recorded, and it's stored online. So the online portal, it's called Monitor My Watershed, and anybody can log on from anywhere at any time. You don't need to create a username or password. It's really easy to use. It's fairly user-friendly. Anybody can view this, and so I want to walk you through just a couple slides to orient you with the web page for those of you interested in going on and seeing this data. Okay, so when you go to browse sites, you're going to see all the different stations in the basin. So Stroud was not kidding when they said they really didn't have the bandwidth to take on this program themselves anymore, that we really needed to start helping with, getting these in ourselves. They've really blown up over the years. There's 477 different stations throughout the Delaware River Basin. They've even started to sell them to outside organizations outside of the DRWI initiative. So we now have a really, really robust set of data, definitely for the Delaware, and also we're starting to get out of that reach. And so we're really happy to be a part of this. If you go and zoom in and click on one of these sensor stations and you go to view data for this site, it's going to prompt you to a window that's going to look a little like this up here. Each of these boxes relates to a sensor. So you have connectivity, water depth, depending on the sensor. If you were to scroll down, you'd have water temperature, air temperature, and all your different sensors. And this is actually showing you the real live data coming in, being transmitted from the stream. Ours are set to record data every hour. And so every hour we can log on and see what's coming in. And if you want to know a little bit more than just that quick snapshot, you can click the little arrow inside the square, and that's going to bring you to the time series analyst. And that will bring you to this page. And once you're in here, then it's really a matter of plug and play. You can really go to this, anything. You can put as many sensors on here as you want on this graph. You can put as many parameters on here. So when I say sensors, I mean the actual stations. So ours up and downstream of the dam, we could put them on the same graph. We could pull those in. We can put different parameters. So here we have air temp versus water temperature. But what I find to be really cool about this is you can actually pull in other sensor stations in other watersheds. So if there's somebody sampling on a stream in Pennsylvania that's very similar to a stream we have in the Paulins skill in terms of the landscape around it and in terms of what we'd see in water quality, you can compare those two data sets, which is really, really useful. And so again, this is a really great new program for us. We're really excited to be a part of it. We're really excited to have more of these in the Paulins skill. We hope to, in time, have even more of these in the watershed. But I think the the bigger importance of this program is not only do we have remote data that we can, sit on our couch and view in a live format, but you have this entire community of scientists that are all using the same method of data collection. They're all working in very close by streams that are all draining to one common point, which would now be the Delaware. And it really has created this community of people that can share lessons learned and share data. And so we have a wealth of data and we have a bunch of people to talk about it with too. So it's a win-win situation. And as much as I'd love to say we can just sit back and enjoy the show now from our couches and our laptops and just see the data come in, it actually isn't that easy. We have a long road ahead of us. We are definitely in it for the long haul. It's going to take decades to see some of these changes. Some of these water quality changes, we may be a little bit more immediate, like the dam removal projects, right? You might be able to see something very instant, those pre and post. But a lot of these changes that are happening in the landscape, like our protection, our dam removal, and our trees, those are all great, and it's important that we're doing it now because it's really going to take a long time to really see these water quality values change. And so our hope is by setting up the baseline data sets now, that in future generations, our future scientists can pick up this information and look back and see all the great work that was done in the Paulins skill, see what the water quality was then, and say, oh my gosh, look at how much better it is now, right? That's the big picture end goal. And so I really hope you all enjoyed yourselves today, and I want to thank you all for tuning in, and I hope you learned a little bit more about our program, and I would be happy to answer any questions.
Okay, here's a question for you, Michelle. For how many years will you continue to collect this data?
So this is actually part of a 10-year measures and monitoring program. And so we started in 2015. We anticipate collecting this information through 2025. We would love to see past that possibly a citizen science program. So maybe TNC isn't out there collecting this information, but maybe have the community out there collecting this information. That's definitely something that a lot of other watershed organizations do. It's a really effective means of collecting the same information. We have the knowledge and experience of how to train citizen science community members. So that is definitely something that we would love to see happen after this program.
Mm-hmm. Okay, is anything that you're doing going to be reflected in state and federal policy?
So policy from the water quality monitoring work, I wouldn't probably tie it to that, but I will say that right now, so the way the state works with water quality data is they actually will accept your water quality data if you have a state approved quality assurance project plan. And so if you have one of these quality assurance plans, or QAPs we call them, you can then submit your water quality data to the state, and then they can use that information in their statewide assessments of streams. And so the state goes out and collects this information and they assess our streams, and we can use this information to help with those stream assessments. So for instance, they designate certain streams as not meeting or meeting certain designated uses for recreation or for fish. And so if our data was showing something that actually didn't meet their standards, they could potentially use that information to, designate that stream as not meeting standards and then go in and do something about it, if that makes sense.
Mm-hmm. Okay, thanks. Okay, and just in case not everyone is reading the chat, there was a question that Barbara and Beth answered in the chat, but I'd like to just point it out for those who may have missed it, why the County Line Dam is coming out earlier, even though it's upriver of the Paulina. And that it's mostly related to the time needed to acquire the permits. Also, county lines on private property, so we only have one owner to deal with. Paulina is owned by the town of Blairstown, and DEP did the design and engineering study, so we needed to work with their engineering firm. And let's see, we've got a couple more questions that just came in. Will you be sharing the link to the remote sensor?
Of course.
Yes, you will, right? And are neighbors and local citizens getting behind this initiative?
So not yet. We don't have like a citizen science program by any means. We do have some landowners in the watershed that we work with and have worked with simply because they let us collect data from the streams in their yards. So, but we are looking to really build that bigger initiative and build some sort of citizen science program in this watershed.
Okay, looks like that's it for questions, unless anybody else has something.
Well, I just want to add thanks to Michelle, and she's been working on this very hard for a number of years. None of this stuff happens immediately, right? We all have to exercise our patience. Between Michelle and Beth, of course, Beth Styler-Barry has been doing so much work in terms of the entire health of this entire watershed, and we are just proud to be working at the level of the entire watershed. You know, individual projects are nice, but when you take into account the entire watershed, that's a whole different level of having impact. So we're proud of that. I'm proud of our team who has been working through these COVID challenges, but we never let that stop us. We're continuing to do that work. So, and we thank everyone who's on this call for your support, because without your support, we couldn't do this. I'd also want to thank Bill Levins and the Levins Foundation, who helped us on purchasing this equipment, and also other folks who are on this call who have consistently been supporting our work in the Paulins scale, including especially the Post Foundation and others. This work is not done by ourselves. We know what we want to do, but we need the support of others in order to accomplish it. So I wanted to add my thanks, not only to those foundations, but to everyone as individuals for the support you're giving this program. I especially want to welcome Keith in his role with Trout Unlimited, because of course trout are one of those charismatic species that many people care about. And Keith, we welcome your partnership and help in figuring out how to make this the best habitat for our native trout and all kinds of trout for fishermen. So I really thank you for that partnership.
We do have a couple more questions from Dean Blametti. When citizen science opportunities do arrive, please let Dean know. Trout Unlimited members would be interested in that.
Yep. I was just exchanging words with Dean, since we're neighbors. He lives in Sparta, I live in Byram. So I figure we should get together and go out and kind of wade in the stream, especially while it's hot.
That would be
and
great.
I did want to add my thanks too for Hayden Watson's support. They've also contributed toward the purchase of equipment that we use in all of this testing.
So I see we have a couple of additional questions. One of them I'm definitely going to take, but I also just wanted to take a second to thank everyone as well for listening and to let you know that we're very grateful for the continued support. It does, as Barbara said, make a huge difference. I wanted to remind everyone to join the next Conservation Connection. It's entitled Investing in Salt Marsh Restoration, and I'm sure that you'll be contacted. That's August 5th at 1 o'clock. But for right now and for the rest of the questions, if you wouldn't mind, or I think it will make it easier for you if you go back to gallery view, and you'll be able to see all of the staff. And I'm going to just take a quick second to talk for a minute about hyperhumus. Hyperhumus, Michelle pointed out on the map in one of her original slides, and that is an area in the headwaters. It's now a state wildlife management area. It's an area in the headwaters of the Paulins Gill that was really kind of devastated through about 75 years of peat mining. You know, kind of effects in water quality, effects in habitat. And so the Nature Conservancy has worked over the past, I guess it was just about when I started, so it's coming up on 4 years, on soil and water studies, on a restoration plan design. So it's, it's been a slow but very steady slog to get to the point that we are now at having a restoration plan, even having a pre-application meeting with the DEP, so to get the kind of preliminary blessing on that plan. And then we hope to continue forward to permitting sometime in the not too distant future. And again, great thanks to the Post Foundation on that, because they've really kind of taken that area of the Paulins skill under their wing, and it's, it has made, it has helped us to get in 4 years to a restoration plan that realistically could have taken a decade or more if we were, if we didn't have their assistance.
Everybody's very quiet today.
Yeah,
no more questions?
Any questions?
I mean, we're all dying to get out into the river and slosh around like we saw in those pictures.
Okay.
Yeah, no more questions.
If I could just make a quick comment. So thanks, Barbara, for the welcome. And I just want to say that coming to TU in this area to see all the data that was already being collected in the pollen scale by TNC, which is really exciting to see. This is really important information for us to plan restoration activities and try to figure out where trout can persist, either wild trout or stocked trout that are recreational fisheries. So this is really great information. I thank Michelle a lot for collecting all of this, and we're really excited to see what we can do with this information and how we can use it to plan for the future. So thanks, everyone.
Right.
If I can, I'll just touch on the citizen science opportunity and question around that. So separately from, the monitoring work and some of the more on the ground construction type work, we're also working to help to build capacity in the watershed itself to kind of continue these projects and the stewardship of the Paulins skill down the road. So, it's great that all of this work is getting done, but we want to really grow and help to put in some real good leadership of a watershed-wide stewardship program. So we have been meeting with municipalities, our partner organizations that also work in the Paulins skill. We've had a lot of, probably at least a half a dozen meetings or so that we call Paulins skill collaboration meetings. And from that, we've been able to draw that there is definitely an interest on the ground of nurturing that grassroots efforts and growing that into something a little bit more formal that will allow, again, that sense of stewardship on a community-wide basis, what we think of as watershed thinking, right? Let's think outside of our municipal boundaries, but think within the watershed as a whole and what will benefit that. So one of the things that we're working on is to get some local, some kind of homegrown effort going with a homegrown lead. So TNC is working on that.
Beth and Michelle, can you tell us generally, how does the Paulins skill water quality compare with water quality in some of the neighboring rivers?
Sure. So we always say, and we started this initiative and it was called Good to Great, right? And we always say that the quality of the water in the Paulins skill, it's not terrible in that it hasn't reached these like really polluted levels that we would see in some of these urban areas in New Jersey, but it's not quite as high quality as we see in the Flatbrook and those really protected areas up in the Delaware Water Gap region. And so the work we do, we know that it's not so far gone that there's still hope of bringing it back to those really good conditions that we see up in the Flatbrook. And so kind of falls somewhere in the middle, I'd say.
I think the issues that we see in the Paulins skill are very typical of rivers in northwestern New Jersey, and some of those issues are, changes made to the landscape to facilitate farming. So a lot of what Michelle has done with the floodplain restoration and the replanting of the riparian area will help that. And then The other heavy handprint of humans are those dams. So removing the dams and then, trying to restore the hyperhumus area. The problems that we're having are not, as Michelle said, are not kind of industrial kind of pollution, but just more the historic land use that we're trying to kind of restore back to a more naturalized situation.
If you remember as far back as the 50s and 60s, many of you will recall that that area of New Jersey had many, many, many dairy farms. And so a lot of the floodplains were used by the dairy farms for the cows to be able to go down and wallow in the stream. So that certainly had an impact, and that's some of the work that we're doing to help repair some of that damage to those floodplains.
Okay, if anyone has questions for any staff or just wants to say hello or make that face to name connection, we're happy to stay on.
Hi, it's Dean. I have one question. In the Paulins skill, have you seen a lot of stormwater issues and septic problems, things like that, affecting the water quality?
It definitely does affect the water quality. However, in our program, that is just not something that we study intensely. So I don't have, too much info, but a lot of our partners in the Delaware River Watershed Initiative, I know they're working in a lot of the lake communities to help address some of those stormwater impacts, leaky septic systems and all that. So like Barbara said, in addition to the farmland and the cows that used to, poke it up the streams, our other kind of big pollutant is a lot of these lake communities that drain right into the main stem. So it's definitely up and coming work that will be happening to target that in the coming years.
Well, I would also point out that with hyperhumus, it's located right near Newton, where a lot of the big box stores and that are lined up sort of right alongside of where hyperhumus is. So that's always a challenge, development and impacts on clean water. These are all kinds of things you have to take into account when you start doing work on restoration, as you probably know. So we're concerned about it, but there are certain limits to what we're able to do, but we can certainly address those impacts as we come across them.
So if you want to watch some of the effects of stormwater, you can bookmark that Mayfly link that you're going to be sent, and you will see, for example, after a storm, you'll see the turbidity increase, you'll see the water temperature increase, you'll see conductivity, especially in the winter, increase, because you'll start to see the stormwater entering the stream. So we are able to track some of the stormwater by virtue of changes in water chemistry.